So now we are still back to what? Isotope what? Weighing. You know, isotopes are atoms of the same element with the same atomic number, different what? Mass number. They will have the same number of what? Protons, but because of the fact that the number of neutrons will be different, they will have different what? Mass number. Take a look at these isotopes of what? Uranium. What is the atomic number here? Number of protons, 92, as well as number of what? Electrons, 92, 92, 92. But what do you have as the mass number here? 238, 235, 234. Definitely, you know, to find the number of neutrons, you subtract 92 from this. The number of neutrons there will be different from the number of neutrons there, will be different from the number of what? Neutrons here. So differences in neutrons is what actually causes what? Isotopy. So a sample, tell us challenge, a sample of uranium contains what? Contains 70% of what? Uranium-238. 20% of what? Uranium-235. And 10% of uranium what? 234. Find a combined relative atomic mass of what? Uranium. We cannot pick this alone, 238. We cannot pick this alone, 235. And we cannot pick what? And we cannot pick 234 what? 234 alone. Hello, are you following me now? We have to find a compromise number that we will choose as what? Relative atomic mass. Now, how do we find a combined relative atomic mass? The compromised mass. Now, what is the relative atomic mass of uranium-238? That would be equal to what? 238. What is the relative abundance? 70%. What is the relative atomic mass of uranium-235? 235. What is the relative abundance? 20%, according to this question. What is the relative atomic mass of uranium-234? 234. What is the relative abundance? 10%. So, what will be the combined relative atomic mass? It's simply, really is the notes, the formula is in the other note. Relative atomic mass of an isotope times relative abundance of that isotope plus relative atomic mass of the second isotope times relative abundance of that isotope. Then, if there are more than two isotopes, relative atomic mass of the third isotope times what? Relative abundance of the what? Third isotope. In this case, 238, relative atomic mass, relative abundance 70 plus 235, relative atomic mass. What is abundance here? 20% plus 234. What is the relative abundance? 10%. Everything divided by what? 100. So, this is the math, which is equal to what? The whole addition. 23770 divided by what? 100. So, the combined relative atomic mass is equal to what? 237.70. You cannot see that the relative and the combined relative atomic mass is not 238, it's not 235, it's not what? 234. There's something in between the three. You cannot see that the answer 237.7 is nearer to 38 than the other what? Isotope. The relative atomic mass of the other isotope is 235 and then what? 234. Why? Because 238 has the most relative abundance.